The other one is more special. The SMT process we just talked about, and our welding process, crimp process. There's also a more special one. It exists, but most likely you've all experienced it. But it's a process you're probably not aware of. This process, we call it in the secondary processing. It's our connector. For example, I went to the customer to weld the plate or carry out preliminary installation. We call it secondary processing. The profit release of the connector in the secondary processing. This is a very special, also very little attention, but it's really, really important. Secondary processing. Because saying, why bring this up alone? Because we just talked about it earlier. Our connector products, whether it's the injection molding process, it's still the stamping process. It's thermally stressed. That's what our stress is. There are both thermal and mechanical stresses. What about these two attractive forces? We've all studied physics. Release of attractive forces. It's been a very, very long time. A slow process. But what can we pass? By adding by high temperature or through some external force? Allow stress to be released quickly. What about stress relief? It's both good and bad. If it is within my control, I release the stress. This is for my entire system. This allows the system to maintain a relatively stable state, healthy state. But if my stress is relieved, is it out of my control? Then it may cause some irreversible damage or cause the whole system to fail. We just talked about, for example, our injection molded parts. The injection molded parts mentioned earlier are during the high temperature forming process. It will be due to thickness. What about this whole structure? An even wall thickness or some structural reason causes heat dissipation in different parts of it will be different. Will it form this internal thermal stress? This internal thermal stress shows the greatest performance when released by temperature. It will have some deformation and warping, even pits, a phenomenon like shrinking pits. Then this thermal stress, if I have it at SMT, during the secondary processing process caused by temperature, the most common one we are talking about is SMT. Of course, you can also have wave soldering, temperature involved in such as secondary processing. If this thermal stress is released again, at this time, our products, there will be some things we don't want to see, such a change one by one, more common. For example, one of my products looks like this. Do these needles below me need to be welded? This is an SMT needle. This is my socket. This is my mating interface. If this product is in the SMT process, my product itself, because the wall thickness design is not very good. Or am I in the process of processing? Because the mold temperature is too high, my heat dissipation effect is not particularly good. But what? When my product first came out, it still works. Then if you go through SMT, after such a process, I tell you, after the SMT high temperature of this product, it is released by secondary thermal stress. There is a high probability that the product will appear like this. The media interface we're talking about, there will be such a deformation. That's an exaggeration, of course. There is such a deformation. Of course, it could also be such a deformation. This deformation takes. It depends on your shape and your structure. The problem of wall thickness, of course, according to your material choice, is also relevant. Then there will be more relevant factors. Well, it mainly depends. The structure of your design, it's your thermal stress. How was it released at the beginning? What about this time? Will appear. It's good to hand over my product. It's good to hand it over to the customer. Then the customer performs secondary processing. You will find that your product is invalid, or there will be relatively large areas of defects. It is because of this secondary release of thermal stress. That's same. We have the same mechanical stresses. Mechanical stress can also occur under certain special conditions. For example, under the condition of external force, or this. Of course, there will also be reasons because of the temperature. A secondary release is also performed. That's the main thing. Like us, for example, there are often some terminals with this structure, right? We often have this kind of secondary bending terminal. There is simply a bent terminal. Such a structure. There's even these circular structures. Is that so? then this structure. If we are in the process of forming, its mechanical stress has not been fully released. For example, in the XZ structure, I'm all in one go. I am not slow. Did we just talk about it? You have to take into account this modulus of elasticity of the material. Consider the question of its yield limit. I'm all disposable. What I'm molding during this forming process, because of its own structure, plus this piece of it, the reason for the material itself. There's no mechanical stress on this piece. We've all done stress analysis. We all know that. Mechanical stress is concentrated in this area. In this area, concentrate on this one. Well, 2 reasons. First, because it is made. Mechanical stress during formation. I didn't release. The second is our own materials. The stress intensity is greater. So in the process, we are in the process of processing. If it appears, I will break it hard. Or is its position not very good? I'm going to apply external force to it. In the case of external force, or in this environment, also under high temperature. Sorry about this one. Its stress will also be released. Once the stress is released, even if you fix this place, I'm sorry, it's going to be in a different position. So that's why there are some products of through-hole solder plates. After we finish the through-hole welding plate, you will find the position of the other end of its terminal. They all ran away. There's a release of mechanical stress. Yes, of course, mechanical stress is released in various ways. Is that why? So what about this piece? Is a theoretical? Or is it a slightly more advanced one? It's a special failure mode. Everyone knows about this. Maybe I've seen a lot. Systematic analysis may be less than that. What about here? Just a reminder to do some key attention in this area.